I am building the nose block. Here's my stack. Has alternating grains. First thing I did to start the nose block was I made the piece that fit to the frame. This fit is critical for repeat performance as far as your trim settings. So I have it marked already with a pencil dot to the top. And here is my stack. It's got them gradually decreasing in size. I need to glue these together and then carve out my nose block. Looking at the gollywog prop, you can see the alternating grain color difference. I have a piece of plywood up front to support the nose button, front bearing, and I have a piece of plywood on the back which supports this adjustment plate and the stop screw. I got an idea I want to do on this nose block. With this big a prop, I want to put an additional sheet of plywood right in the nose block here. So the stop screw would be supported on the back, and instead of just hardening the screw hole in the balsa with CA, I could also have it going through plywood. There's the nose block all glued together, and I have the shape of it, the overall shape of it, sanded. And the way I do that is I've marked the center on the back, and then I've transferred those lines with my square off my building board to the front. And then I am following the sides of the fuselage and getting this curve to transition from the curve on the frame evenly down to these 4 quadrants you see on the plywood on the nose. Here is the plywood I laminated in the nose block for my stop screw. It's going to go through both of these sheets of plywood for better support with this bigger prop that I have on this model. So 3 layers of plywood. The back plate, which will support the stop screw, and also the adjustment plate for the right and down thrust. This plywood plate in the partway in to support the screw, and then the plate on the front that will support the front bearing. Next, I have to round these corners to match the edge of the fuselage, and then radius the nose, transition that radius on the edge of the frame to the radius on the nose. I have the corners radiused on the nose block. I drilled through in my milling machine a perpendicular hole through it, and I have drilled with this tapered drill bit, getting the hole opened up in the back for my down and right thrust. I'm checking it here with the protractor There is 6 degrees. I need 5 minimum, so that's down thrust. And I'll need 5 degrees of right thrust. So there is 6 degrees right thrust. Here is the tapered hole in the back. You can see it's offset that way to my crosshairs. There's the top of my nose block. So down thrust and right thrust. Here are all the components for the front end assembly. Stop screw, thrust bearing, drive dog, piece of copper tubing, 2 washers, prop shaft, and wire for the spring. The copper tubing and the washers have to fit over the 93 thousandths prop shaft, and I've found 47 thou for this size assembly to give me the right spring tension. Here is where they go in the assembly. This is the thrust bearing, the spring, 47 thou spring, copper tube, 2 washers, the drive dog. The way this works is when the motor is fully wound under tension, the prop shaft clears the stop screw right here. As the motor unwinds and relaxes, it goes forward, catches on the stop screw. When it's under tension, it's pulled back to clear the stop screw, and it's compressed against the copper tubing. This spring right here, between the diameter and the height of it, and I'm making a wrap and a half, and then it's got a wrap around the prop shaft right down in here, and up front there's a wrap around the prop shaft. That is the full assembly and how it works. The drive dog has a set screw onto a flat on the prop shaft, and then this pin goes into the center hub. I have the hook bent up on my prop shaft and cut to length. I have it bent so that this crocket hook clears the throat, and when it's pulling in line there, the bottom of the hook is on the center of the prop shaft. You can see that when you spin it too. It stays right in line with the prop shaft. I have the location marked for my stop screw. So that's right here. And I had to figure for, I'll never go up or left thrust, but with it centered, it will catch the screw. And if I go full down and right thrust, see that movement there? It's all the way in that corner, 5 degrees down and right thrust, it's centered up on the stop screw. I have the hardware in the front of the nose block done. I have this spring bent up. Thrust bearing is in there, the 2 washers, the copper tube. I have this set screw just snug down on here. The drive pin on the drive dog reversed. Just have the drive dog reversed. Haven't drilled that hole yet. I am checking out all the mechanics of this. So here is where my stop screw is going to be. And I'm looking at, as far as the bending of the spring and the length of that copper tube, when it compresses all the way, those are perpendicular, the two legs of that spring, so it'll seat against the copper tube, and I'll have enough clearance back here on the hook to clear the stop screw. And when the spring releases, what stops it from going forward will be this bend here on the prop shaft. That'll be against the metal plate for adjusting the thrust angle. It'll go against the metal plate and come up against the stop screw right there. To wind this spring, I used a 1/4 inch drill bit, wound it as tight as I could around that shank of the drill bit, and this gauge wire, it releases, comes out the size I want. On the prop shaft, the hook, I use a 3/16 drill bit, clamped it to my bench and bent it around that shank. It's much heavier gauge wire and it tends to come right out on that size. Here's all the pliers I use to make the bends. I also, like these needle nose pliers, I made these small bends down here. So that's about as heavy a wire as I would care to bend this prop shaft, this 93 thou prop shaft, without wire bending equipment. It's done. I have everything made now and fitted, ready for final assembly. This is a plate that goes on the back of the nose block for adjusting the thrust angle. That's roughly the 0 position, and these two holes are the screws that clamp the plate down. This is where my stop screw goes. You can see I have clearance cut out for adjusting a thrust plate for right and down thrust. I'm going to put the screws in for holding this plate down and the stop screw. So these marks are actually 1 degree increments. I know how far I had to move the shaft when I was checking it with the protractor to get 5 degrees. So I'm just dividing up the overall movement with 5 lines. I've hardened all those threads with CA, the surface of the plywood, and I've hardened all these edges and fit this into the fuselage. The next component to go in there is the prop shaft. So there is 0 degrees down thrust, and there is 0 degrees as far as left or right. I have nylon nose button CA'd in the front. Next component is the thrust bearing. Then the spring. Then the washers. Well, one washer. brass tube and the other washer. So that is the order for that assembly. I've drilled the 16th hole for the drive dog into the center hub. So this has a set screw down in there and the through hole for the prop shaft. I have a flat ground on the prop shaft for the set screw. Lock that on so it won't go anywhere. And we put the prop shaft against the stop screw. Line up the center hub to the nose block. Hold a little down pressure because now we're compressing the spring. There we go. It's sticking it through a little bit too far. And there is the flat on the prop shaft, adjusting the position so when it's against the stop screw, we have our blades positioned for going along the side of the fuselage. Then we have the rubber bands. I got the pins in here. I'll show you where they are as soon as I put the rubber bands on. A little tiny pin just off center of the prop shaft so this spring can be upright in that position and clear it. And up along the top edge of the blade I have another pin. So there is the energy for folding it instead of just the slipstream. The air from the plane moving through the air, folding back. They don't fold back positive, they tend to hang a blade. So this pin here is off to the side, and this one is up along the edge of the blade, just like the other one. And there is a complete folding prop set up. All our hardware in the front here, and here is our screw, stop screw, and when you compress the spring, there's our clearance on the stop screw. I'm going to adjust for 5 degrees down and 5 degrees right. So I'll slide this plate from the back so it'll go up and to the left, which will adjust the prop shaft down and to the right. There is the adjustment for, so I shifted the plate up. So I'm on 5 degrees on the up, and I'm on 5 degrees to the right. Might be a little hard to tell on the camera, but there is our down thrust. If I rotate, come up against the stop screw, there is my right thrust. I don't keep track of my hours modeling, but I don't think it'd be a stretch to say I got 50, maybe 70 hours into this. I think we should try it on the plane. Wow. Is it worth it? All those hours modeling? Can't get these on Amazon.